Have you ever wanted your laptop or phone to run faster because it's just too darn slow? Or your electric vehicle to not take 3 hours to recharge?
Or to convince your grandpa that solar panels aren't expensive anymore? Well, a new pure carbon material that's stronger than diamonds and as thin as an atom can help. Graphene!
Do you know what graphene is?
Graphene is a 2D material composed of a single layer of carbon atoms. It has high resistance, high electrical conductivity. It's tough, flexible, and light. It was discovered in 2004 in Manchester.
Thank you. Graphene can be made in many different ways, but one way is through a process called mechanical exfoliation. This can be shown through a simple experiment using Scotch tape, a graphite pencil. So what you do is you take your pencil and you draw a nice circle like so. And then you take your tape, you put it on that circle that you made. Take off. And then you can see you have the graphite now on the tape. So from here, I want to mechanical exfoliate it. So you do this by putting the tape together where the dot is, split apart, and you have 2 graphite circles. You keep doing this. Alright, so now you're at a point where you split the graphite into very small layers. Now this whole thing is not graphene. You have to go in with a microscope and see and look for individual pieces of graphene on this tape. Unfortunately, we do not have a microscope, but we have a very advanced camera that's going to zoom in and find the graphene for us.
Now, from the Scotch tape method we showed, you saw layers of graphite being mechanically exfoliated into thinner layers, making graphene, but that's not super practical. So let's look at other methods. There is a process called chemical vapor deposition, where we begin with hydrocarbon gas that is then heated up and pressurized and deposited onto a metal substrate. From there, it is again transferred to another substrate, and wouldn't you know it, we have graphene. Finally, we'll look at a process known as epitaxial growth. This process starts with a silicon carbide wafer that is heated up to blazing hot temperatures, where it then begins to sublimate and expose a carbon layer on top. This layer is taken and, you guessed it, we have graphene.
There are many different applications for graphene, some of which that you saw earlier include computer chips, EV batteries, solar panels. Graphene enhances the efficiency and also the performance of all these different applications. This is due to graphene's impressive material properties.
While the applications of graphene can make products more sustainable, such as solar panels, the production methods that they use and the feedstock, like graphite, could also be more environmentally friendly by using bio-based materials instead.
Bio-based feedstocks are more environmentally friendly because you can use waste products from things like hemp plants or oil palm shells, or even this tree.
It is anticipated to grow rapidly in the coming years. Right now, most of the production is limited to laboratories, so we're relying on funding to really promote research and development and its scalability.
This will require large corporations to align with research and development so we can get new graphene-enhanced products on the market, and you can see graphene in your EV batteries, your solar panels, or even your phone.